Hello, everyone, and welcome. I'm just going to give it a couple more seconds to make sure people can connect via audio. So thanks for joining us. For those of you that just joined, we're going to just give it another 30 seconds for folks to connect via audio and make sure that they can get settled in here. So thanks so much for joining us. All right, it looks like most people have connected. I want to welcome you to this webinar on exploring majors for new and evolving economy. My name is Christopher Tremblay, and I serve as an independent education consultant with Estrella Consulting, and we are the host of tonight's session, and wanted to just introduce you to Estrella Consulting. If you're not familiar with us, we are an organization based out of Ohio that helps families navigate the complex college and admissions processes, and we're a team of 12 professionals who help students pursue their dreams. So thanks again for joining us today. There's many ways that you can connect with us at Estrella Consulting. We have a free newsletter that you can subscribe to get tips on the journey. You can follow our blog. You can also sign up for a free consultation with any of our team members, and we encourage you to also follow us on social media. We share lots of information that way as well. So again, our website is estrellaconsulting.com. So let's get to the exciting part of this session. We are here to talk and introduce you to some cool new majors in urban technology, microelectronic engineering, geodesign, human security, and geospatial intelligence. And if you don't know what some of these things are, then you're in the right place, because you're going to find out all about them. So we've assembled an incredible panel for this session. So you will get to meet our colleagues here, and I'll let them introduce themselves as they introduce their programs to you. So we're going to go ahead and get started, and I'm going to turn things over to Brian Boyer from the University of Michigan. Brian, welcome.
Thank you, Christopher. My name is Brian Boyer. I'm an assistant professor of architecture at the University of Michigan, the Taubman College of Architecture and Urban Planning, and also the director of the bachelor degree in urban science, which is what we're going to talk about tonight. So you wouldn't be the first person to Google urban technology and wonder what that is. The way that we think about it is computation, networking, and connectivity are changing cities. So for instance, you've probably spent some time, I'm guessing at one point or another, in the back of a car that's driven by an Uber driver or a Lyft driver with an interface, something like this. And if you're that person, it can be incredibly convenient. But if you're the person who's not in that car that happens to live in the same city, you might be feeling the impact of increased traffic, increased congestion, whether you like Uber or not, whether you use it or not. And so what's important about this is that technology, which used to be something that existed on your computer and only your computer, or your phone and only your phone, suddenly it has urban consequences. And so we want to educate people at the University of Michigan who are able to understand both the physical side of those consequences and the digital side, and that they can really be the folks who can create cities of the future, not just the distant future, but also literally tomorrow, people who are making small incremental improvements across our urban environments. So for instance, there's a lot of discussion and hoopla and excitement about autonomous vehicles, including delivery bots like the one that you see on the screen. But if that becomes the new normal and your sidewalk is filled with those delivery bots, do you have the same feeling of generosity towards them? Or maybe you didn't actually have any generosity to start with. But these kinds of questions about transitions to our everyday experience of the city are exactly what we want to equip our students to think about, and also to be proactive in terms of developing better ideas. So likewise, you might be happy about living in a city that feels somewhat safe, but you might get a bit uneasy when those same cameras are turned towards you. And particularly if you are somebody who doesn't look like me, like a middle-aged white male, right? We know that computer vision, machine learning, these technologies have biases built into them that don't treat all of us equally. And so we feel like these are the types of challenges that we need our best minds involved in, not just from an engineering standpoint, but also from the perspective of design. And so ultimately, the question of whether our cities and new technology equate to dystopia or to utopia is one of design. It's not of how we do it necessarily, but what we do and why we do it, those initial starting points. And so that's something that we want to educate our students to be able to tackle head on. We have the first of its kind program at the undergraduate level. So there's one other program in urban technology currently in the US, that's at Cornell Tech in New York, and it's a graduate program. We bring this to the undergraduate level. The students take a combination of cities courses focusing on urban planning and related topics. They learn how to code and think about the way that software is built and put together. And finally, they learn how to design digital products and services. It's a 7.5 semester program, and I'll talk a little bit more about that in future slides, but they start in the winter, which is January for us here in Michigan. And then we're currently, we've actually just recruited our second cohort. So we're recruiting our third cohort as of next fall. And it's really exciting for us because we're seeing the momentum and the excitement grow year over year. In terms of what you learn in this degree, it's a combination of cities, technology, and design, as I mentioned. In terms of cities, we're really taking advantage of the fact that here in Southeast Michigan, we're very close to a variety of environments, from cities like Detroit that have had more than their fair of struggles, to places like Toledo that have interesting dynamics in terms of the built environment and the natural environment, to places like Chicago that are thriving global metropolis and have all of the challenges and opportunities that come with that. So our students will spend time in the classroom learning from our professors, of course, but we're also getting them out on the road and seeing cities on their feet with their eyes and learning from people who are doing the work of urban change. The second category of required courses is around technology. All of our students learn how to code, they learn how to work with databases, APIs, the kind of basic plumbing, if you will, of digital services. And then they think about and learn about the ethics of those technologies. And then finally in design, we're really looking at the design of software that has physical consequences. So any interface where you press a button and something happens in the real world, that's what we're interested in and really, frankly, excited about in this program. As a layer of, let's call it intellectual breadth or depth, we're also asking all of our students who major in urban technology to then take a minor in one of the things that you see on the screen currently. And so the intention there is really to make sure that as we assemble a cohort of students in the classroom, that we don't have a kind of cookie cutter duplicate, 20 students who all have exactly the same educational experience. What we're looking for is to bring both a humanistic perspective of something like anthropology or history, with more of a fine arts and design perspective, with more of a technical perspective. And we want our classroom to be a mix of all of those. And so we're encouraging and even actually requiring our students to think very broadly about how they're complementing their studies in our program with a minor elsewhere at the University of Michigan. The program, as I mentioned, is a winter start. And so that means that during the fall semester, the students take a gap. They can travel, they can intern, they can do self-directed study. And in fact, that's what we've seen our first students doing during that time. And then they join us in January, and it's off to the races. And what they do is then stay through May and June, which for us is the spring semester. And that gives us a chance to get on a bus and travel throughout the region and see urban change happening and learn about it from people who are doing the work. And so we're taking advantage of this different schedule by having this travel component baked into the experience. And this is what that looks like on the timeline. So in the first year, it's winter and spring, and from there on, it's a traditional fall and winter complement. And technically, it's a 7.5 semester program. So we like to think that our students graduate on time with their peers from high school, even though they had a slightly different starting point for their experience. In terms of after the degree, we really see these students graduating into, let's call it, 4 different trajectories. So they might be working in design in a technology company after they graduate. They might be working as an engineer or something with a more technical focus. It's not going to be every student in our program, but some of them who enter with a background in robotics or computer science or something like that at the high school level, they might excel towards this. And really, we see some of our students taking a more technical role, but frankly, probably not the majority. Business is a huge opportunity for our students. The amount of innovative practices when it comes to real estate, operations, commercial services, housing, mobility, energy, power, et cetera. Almost any of the areas that shape urban life are up for change and are up for innovation. And that requires people who understand the content of those areas, but are also driven just to make it something that has paying customers, has a feedback loop through the market. And so we certainly imagine that some of our students will pursue that pathway. And then finally, research. So for folks who are maybe more driven by policy questions or by the deep needs that we have in urban environments, we expect that some of our students will go on to do think tank or nonprofit work, perhaps even work in a mayor's office or part of the city government. And we're really excited to see that, because this program has been designed to educate the private sector entrepreneur and the public sector civil servant side by side. We don't want to create an environment that attracts one or the other, because actually one of the biggest challenges that we recognize today in the way that cities work is that those two communities often don't have enough of a shared understanding of what the issues are and what the sources of agency are to make a difference. So we're trying to bring all of them together. At Taubman College, we have decades of experience educating architects and urban planners. And so some of those folks you see on the screen now, and we're also collaborating in this degree with our partners across campus at the School of Information and elsewhere, and really bringing all of the resources of the University of Michigan to bear on the program and create a rich educational environment for the students. I think it's also exciting to think about this in the context of a School of Architecture and Planning like Taubman College, where you're shoulder to shoulder with peers who are working on robotic fabrication, working on deep questions of equity around food or housing or mobility. All of that's happening together. And the digital question that we're adding with the new degree program is, in a sense, the thing that has been missing for too long. And so we're very happy to provide this as a way to fill it in. And so what I would say, after all of that, which is the quick overview, and I look forward to questions if there are any after this, but there's also a short video that you can watch via the link that's on the screen here, and I'll go ahead and put it in the chat after I'm done. So thank you so much for your time, and really excited to hear about the other programs that we're going to learn about.
All right, thanks, Brian, for that information. And we're going to go ahead and continue on with our panelists tonight. And I'm excited to introduce Sean, who's from RIT, to talk about microelectronic engineering. So take it away, Sean.
Great. Thank you so much, Chris, for the introduction and for inviting me here. Brian, that was a wonderful presentation ahead. It was really great to see what you were working on as well. So my name is Sean Rommel. I'm a professor and the current program director of microelectronic engineering at the Rochester Institute of Technology. What I'm going to do today is talk to you about my degree program, but I'm also going to talk to you about the semiconductor industry as a whole. You've probably heard about this in the news in the context of a supply shortage. I'd like to give you an idea about what the industry is. We're a part of the combined electrical and microelectronic engineering department at RIT, which means we're really an electrical engineering background in general with a flavor in some material science. When I entered electrical engineering as a student, I really didn't have the first clue that I was going to head into the direction of semiconductors, nor did I understand what they are. So I think it's important to kind of give that overview, who the companies are, where the sales come. I also want to talk about some federal investment that we believe to be forthcoming. I'll talk about applications of semiconductors that are beyond the traditional computer you may have thought about. And I'm going to talk about the big picture of employment in the industry and where our trajectory will be. My snapshot of my program and classes will be relatively brief at the end. I'd like to show you a little bit more of applications and a couple of hands-on things, such as this quartz plate called a mask that I'll speak to you about later in this talk. And I'll mention also silicon wafers. Essentially, you'll see these discs in a video that I will be showing you in a little bit from the company Global Foundries. So in terms of who the players are in semiconductors, you've probably heard of the names of some of these companies before. So companies such as Intel, Samsung, TSMC are some of the biggest names in the business. Some of those companies directly make their products, such as Intel, they're called IDM or integrated device manufacturers. Some companies take designs from others such as TSMC, and then they operate as what's called a foundry or pure play, and they design the chips. This industry has been a thriving industry for my whole time sitting here at RIT and my time in graduate school years before. And almost irrespective of the year, this has been a several $100 billion industry. In terms of where chip demand goes, this graphic was published in the major trade journal for electrical engineers, IEEE Spectrum, in August of last year. And what it basically does is it shows a breakdown of where the demand was in 2020. So as I was explaining to Chris just before this call, what hit the news for everybody was the supply shortages of chips going into automobiles. In reality, the automobile portion of the overall chip demand is only about 9% of the total sales for the semiconductor industry. The rest of it is comprised of other areas where 84% of that are the traditional things you'll think about, such as cell phones and laptops, iPads, smartwatches, and so on. Where automotive is really a small slice. And it turned out that basically in 2020, I think nobody really foresaw the overall demand for chips that was coming, including the industry themselves. They actually had a record year for sales that year. And ultimately, the fabs were operating at capacity. When everything else shut down, semiconductor fabs were literally the cleanest and safest place to be in the world, just by virtue of the air handling and things that go on behind the scenes. However, ahead of the pandemic, there was actually studies that were done at the national level, because when we're thinking chip demand and supply on the news, they're often talking about this in the context of consumers, and things that we want to purchase. However, it turns out that semiconductors are also incredibly important for defense. And so the National Security Strategy highlighted a study, that basically was put together by the Department of Commerce and the National Institute of Standards and Technology. And they talked about what are the buzzwords that we all really think that we need in some of these secure, defense applications, things such as data science, encryption, autonomous technologies, advanced computing, and AI. If you look under the hood at all of those technologies and ask, what is it that enables those things? It turns out it's semiconductors. So, I could give you this whole 37-page study from 2017. I'm going to summarize it like a cliff note here and tell you that semiconductors were really the key. And what they were speaking about was the need for a workforce. So you're going to hear that from me a few times during this talk, that ultimately they knew prior to the pandemic that they needed a workforce that was trained. And the Department of Commerce pointed to the need to have K through 12 undergraduate and STEM education focused on semiconductors, as well as targeted training programs such as co-ops. So I'll mention that the Rochester Institute of Technology, where I work, we have the fourth oldest co-op program in the nation and one of the strongest. The students in my program are required to take a year of work experience with semiconductor companies. I'm in the middle at the end of our semester here of looking through the reports our students put out to their employers and the employers put back to them. Because of that training they have and what we teach them in the classroom, it's incredibly strong having that experience. So if you do want to get a copy of this, I can chat this link to you afterward. But trust me, the one slide here probably will distill a lot of it for you. I mentioned also federal investment. And so you may or may not be aware, but the House of Representatives and the Senate have actually been looking at legislation related to semiconductors. The House has an act that has been passed called America Competes, and the Senate has an act that's called U.S. Innovation and Competition, which is sometimes referred to as CHIPS. Each of these acts are about $52 billion. The two acts are currently in the process of reconciliation. And I'm generally going to stay off of politics outside of this with you all for obvious reasons, but I'll mention that this has been something that's been bipartisan. The Department of Commerce study from 2017 was bipartisan. The government really sees the need for semiconductors, and it sees the need for having a workforce. So much of these acts are going to be talking about how companies can bring more manufacturing onshore, and they're already beginning to do this. My next slide will speak to this in a second. But I've heard through executives, and I'll speak to one of these momentarily, where the semiconductor industry is really in a renaissance that it hasn't seen in manufacturing since 1982. And it's going to be a few years before we really see all of the fruit coming to bear. There's a lot of discussions going on at all the universities in the nation right now, and also with regard to the companies. So to that end, I'm borrowing a slide from an alum of my program, Matt Hicks, who is the manager of the semiconductor fab at Northrop Grumman outside of Baltimore, Maryland. Matt basically took the time to put together a slide showing where a lot of the new fabs are being built. So I understand Chris's team is based out of Ohio. I was just mentioning to his partner that there's a fab for Intel that was announced outside of Columbus, Ohio, and New Albany. It's a mega fab facility that's going to need workforce. They've also announced facilities in 2 other locations, so Intel 3 alone. The company TSMC has announced a new fab outside of Phoenix, and I could go down the line where many of these facilities have been announced. In fact, just down the road from us here, by about 2 hours to the east of me, outside of Utica, New York, the company Cree, which is one of the largest manufacturers of LED lighting, announced a $1 billion fab in September 2019 was going to be built. That fab just opened up on Monday. So we see this kind of expansion all over the nation right now. I'd like to give you an idea of what a fab looks like on the inside. So I'm not going to play the music on this one, just because I find that's not the better way to do this on the video, but I want to show that a modern fab facility is highly automated. This is coming from the company Global Foundries, which is based outside of Albany and Malta, New York. If you could see, there are a series of automated cassettes moving on the ceiling. These are called FOUPs. What I was demonstrating behind me with the silicon wafer is an example of one of these. And basically, as they go through manufacturing, they start from a disk like what I showed you before, and that disk goes into different equipment. We teach what the equipment does. You can see one of the 12-inch wafers going into a tool here with robotics. So what I'm trying to emphasize to you all here is there's going to be some chemistry and physics underlying how these devices work and how we make them, but there's also a high degree of automation in the industry. So you can see robotics, and you can see that there's a need for equipment manufacturers and understanding all of that as well. So the industry has been based very heavily on a device called the field effect transistor. The transistor is the simplest switch. If you think of a simple light switch, I'll work with this here on the light right behind me. I can turn the switch off and on, right? And so a switch basically changes the flow of something called current. We can also do this at a level that is on the atomic level. And these switches are referred to as transistors. I'm borrowing a graphic from Dr. Gary Patton, who visited RAT on April 8th. I'll mention that my program just celebrated its 40th anniversary. Gary was the keynote speaker at our event on April 8th. And he's also a corporate vice president at Intel. He allowed me to use this graphic for these kind of presentations. The reason I decided to show this to all of you was to illustrate just the kind of scale that is being worked on in production. It turns out that companies such as Intel, Samsung, TSMC are all working on building aspects of transistors that are on the order of 7 nanometers by 12 nanometers, or 70 by 120 angstroms, which is incredibly small in dimension. Now, these are the kind of transistors that would go into the chips that we would see a company such as Intel putting into a Dell laptop or such. But that's not the only thing the semiconductor industry works on. So other applications that are there are things such as mobile and consumer electronics. So I'm showing an iPhone 10 here. Additionally, things like solar cells are made by semiconductors, and the same kind of processing techniques that we talk about. So I'm illustrating here an example of a building powered by a solar array. We refer to this as a terrestrial solar cell because it's on Earth. But there's other applications that need solar. So for example, military or anything that's in space needs this. I'm illustrating on the right here the Ingenuity helicopter that's on Mars, and I think just took its 26th or 25th flight the other day. On top of this helicopter, you see this square grid. The square grid here is another example of a solar panel. Only the difference between what's done on Earth and what's done on Mars is the material in the solar panels change. So the wafers I showed you a moment ago were made out of the material silicon, which is basically sand. The wafers that have been used to build these solar panels, which by the way were constructed by alumni of our program at a company called Solero, are made out of 3,5 compound semiconductors because they pick up different parts of light from the sun, and that's how they can keep the batteries on this charged. LED lighting is another thing that I mentioned. So the bulbs I showed you a moment ago when I was turning the switch are LED bulbs. There was a major switch that those who are older on the call will probably recognize in 2014. Prior to that, everybody purchasing light bulbs were purchasing incandescent bulbs. It switched to LEDs. It's now in every sporting arena. So we see that's something as a major change. And companies such as Cree Semiconductor, the company that opened up outside of the Utica area for their second fab, are major manufacturers of LED lighting, different materials than silicon, but a similar kind of fabrication technique. And additionally, there are things known as photonics. So this would be when semiconductors operate as lasers and can emit light and so on. I'm mentioning the photonics here because Rochester is a hotbed for optics. Two of the larger companies in town here are Kodak and Xerox. So you can imagine just the overall emphasis on optics that have been in this community. And so I want to mention photonics because RIT is part of a consortia called AIM Photonics of major universities in the country that are partnered with a lot of the major semiconductor companies. That these are only a few applications of semiconductors. I'll also mention there are things such as MEMS where you can build gears or mechanical things at a very small scale on wafer. So the major message that I want to get through to all of you is that employment in the semiconductor industry right now is hot. I mentioned the 40th anniversary event that we had in my program. We had about 150 alumni attending this event a few weeks ago, along with a number of folks from industry. Regardless of which company was there, I felt they were trying to poach our students. They were at competition with each other, and the folks from the various companies were even basically telling me just 3 weeks ago how they're actually trying to poach folks from groups within their company. And that's because the workforce in the semiconductor industry is actually aging. I mentioned that the industry really took off in the 80s. It took off in response to a lot of the electronics supplies coming out of Japan. The United States really took back over in the 1980s. And so a lot of the people that entered the workforce now are very close to retirement. I mentioned the new fabs that are being built, and there's an increased demand that we're hearing about in the news all the time. When Dr. Patton gave his keynote a couple of weeks back, he pointed to the 4 new fabs I alluded to between Intel and TSMC alone. I had to play back the Zoom webinar of his video about 4 times to make sure I had this number right. But he in fact said that Intel expects that there will be 100,000 new jobs for those 4 facilities alone. And that's excluding support jobs such as sales. So when you think about just those companies talking about it, maybe that number is a little larger than it really would be, but that's the kind of order of magnitude we're talking about here. So not surprisingly, when you look at what my program will do, we've had 100% placement. I've been doing talks, for admissions events for a number of years now. And just pre-pandemic, I would always talk about, what's the placement when you see a bad turn in the economy. So I was always speaking to 2008, ahead of the pandemic, and then the pandemic hit. Long story short, our students were getting co-ops even as RIT was shutting down to go to online classes, even as a lot of the other companies were shutting down, the industry was open. Some of our students, though, want to get a PhD or pursue graduate school. So we're a bachelor's program doing this. There are semiconductor programs, but often it's more at the master's or PhD level. In terms of salaries, the starting salary that our students report back is on the order of $74K. Now, I'll mention that when students graduate, they're not mandated to report a salary back. I believe most do. I can tell you that I heard of a student last year whose starting salary was on the order of $95K, starting in the Boston area. And I know of another whose salary was quite comparable, who started at a job at Hughes Research Lab in Malibu, California. The industrial co-ops currently are at about $22 per hour. Our students are required to report that back to the Institute when they have a co-op. And we fully expect that based on the demand that I mentioned on the prior slide, I'm hearing that everybody around the industry from vice presidents of the companies on down expect that the salaries are going to increase to attract workforce. So our students have gone on to work at companies such as Intel, Micron, which is one of the larger suppliers of memory, and other places that are not necessarily semiconductor companies, such as the US Patent and Trademark Office. So we're training our students to learn how to do the technology, but actually that makes them an excellent patent examiner. We've also placed students at major Research One universities as well as RIT, and also in many of the national labs. One of the largest semiconductor labs at a university for graduate work is Cornell Nano Fab, about 90 minutes down the road from us. Approximately 30% of their staff are alumni of my program. In terms of our curriculum, we have a flow chart that we typically show, and I'm not going to go through every one of these bullets, but I'm going to refer to this kind of at a high level. I mentioned earlier in this talk that we are an electrical engineering program by and large. So we have math, chemistry, and physics, and STEM, and a general education component, as well as open electives. And so a lot of that's kind of in common to most engineering. So what I'd highlight is all of the classes that are in dark blue are traditional classes in electrical engineering, like circuits and digital systems. The classes in light blue are classes where we actually take you into the clean room to do things in our major. So we have basic EE core classes plus circuits and electronics. And then we get our students in the clean room learning how to do some of the things that they will actually do in industry. And that's what helps our students actually land those initial co-ops and land the jobs. So I'll just kind of briefly show one demo, and then I'll be done in about a minute here to pass back off to Chris. But we basically take wafers like the one that you saw, and the industry is responsible for learning how to put metal lines that would become wires. I'm going to do this simple demo for you where we could have aluminum essentially spray painted on the sample through a process called sputter deposition. And then a coating that's kind of similar to the coating that would be developed in photography called photoresist is put on top of the wafer. We would then use a chrome plate like the one I showed you at the start here, where if you can see it's opaque in some places and transmissive in other places. We'll shine UV light through it, and where the UV light exposes, this is like old print photography. So the way that that would be applied is through something like a pipette. This is a manual dispense of this photoresist here, and you're going to see it's going to be spun. So if you spin this at very high speeds, 3,000, 4,000 RPMs, it turns out that that photoresist spreads and becomes thin enough that we can then begin to do an exposure. So here's the spin step. After we do a spin, we can take it. Here's an example of a different mask plate my colleague Carl Hirschman is holding, and we can expose that material with UV light. When we expose with UV light, it changes the bond structure where it's not blocked by this chrome mask. You put it in a plate and you develop it, much like old photography would be. If you could see, some patterns are gradually beginning to appear. And now this acts as a stencil to block where a chemical process called etching can take place. So this is illustrating how that same sample that had aluminum on it is being put into a bath where we can actually etch some of the material away. And after about 2 minutes, where we did not have photoresist, we find that all of the aluminum is gone, and only where the photoresist is where we have actually had that material become etched. So I'll mention that RIT is doing on-campus tours. Feel free to contact us and come out and visit. We're also doing virtual tours and video conversations. And I thank you for your time. If you have any questions, I would be happy to answer them. And I'll pass back to Chris here.
All right, thank you so much, Sean, for all of that information. Very fascinating to learn about it. We are now going to turn things over to our colleagues at the University of Southern California. So it's my pleasure to introduce Stephen Fleming. And Stephen, I'll let you further introduce yourself and share any slides that you would like to.
Okay, great, Chris. Thanks. Let me go ahead and share my slides. And I'd also like to introduce my colleague, Dr. Lele Dewan, who's here with me. And so we're going to be actually doing the presentation from same room instead of sending you back and forth to different Zoom rooms. So let me share a screen here with you. Hold one.
New share.
What's that?
So click on the new share.
I'll let you do it. Okay, just to make sure everyone's got one screen up now that says new economy majors in spatial sciences.
Good to go.
Good to go, great. All right, thanks. So yeah, what I want to talk to you all about today is this discipline called spatial sciences, and then we're going to give you a couple of applications, one in a field called GeoDesign, and then the other one that we're finding in more and more use in the intelligence community that's around human safety and human security. So a couple of degrees that we built out here at University of Southern California in order to support that. And just to be very transparent, there's a number of schools that are doing that. We're not the only game in town on this one. We're one of actually 20 schools that have been doing the work in the human security, geospatial intelligence, and then there are a number of other schools around the nation as well as internationally that have been doing work in geodesign. So we'll start with this. This idea of where spatial sciences fit and what spatial sciences is. I'll quick history lesson when the advent of global positioning systems, which is the United States version of this thing called global navigation satellite systems, came into play a few decades ago. It started placing location and time stamps on a whole bunch of the data of the world. So if you roll the clock back, what you would find is the data did not have a location and time stamp. Today, primarily because of that technology, global positioning system technology, the majority of the world's data today being collected comes with that. So the question is, what do we do with this data that now has this very rich attribution of location and time, which is essentially spatial sciences, spatio-temporal data? And the answer is we can do a whole lot with it. And what we're finding is that there's a number of academic disciplines that are asking the question, what can we do with that data in our field? Maybe said a different way, how do those disciplines translate into industry requirements? And what can those industries do with that type of data? So what you're finding is a number of folks with these skill sets are now finding their way into academic units that teach it. And what we like to think of is you think of a Starbucks coffee cup, you can get different sizes and maybe some different flavors of coffee. Translated into maybe different academic disciplines or possibly in different industries that would follow. And each one of them, assuming that you don't like your coffee black, each one of them can make just a little bit better with some spatial sciences. So maybe that's the idea of the creamer that you would add into it. So just a visual of maybe how you would see it. What we're finding is that spatial computing is now being done anywhere and anytime. Just ask yourself, how much do you depend today on having a spatial science application on your device that you carry around with you or have actually with you in your vehicle? How often do you reference it in order to solve problems throughout your day? There was a time that you had to solve it differently. You had to ask somebody for directions. You had to look at a map. You had to maybe write down a series of threaded descriptions about how you would get to point A to point B. But what we're finding today is that spatial sciences is now very pervasive in our societies. And we find them often used in solution sets that we ask questions about throughout every day. So a very hot topic that we now find available for us to now explore through academia. So we can take that hot topic and that hot interest and now apply it in the classroom. And actually you find educational programs that are now rooted in this, this concept of spatial sciences. So let me turn it over to Dr. Dewan, and she's going to continue the discussion with some of the guiding principles and enabling technologies, and I'll come back and talk to you about some of the human security and geospatial intelligence applications. Dr. Dewan.
Thanks, Steve. Hi, everyone. My name is Lele Duan. I'm a lecturer here at Spatial Sciences Institute. So following what Steve just talked about, so basically in spatial sciences, we have a whole suite of software that we basically use. And this software, as you can see here, ranges from the traditional mapping software such as Google Maps that we use every single day to some traditional drafting software such as SketchUp that usually architects they use. And in spatial sciences, we actually use all of them. So other software such as OpenStreetMap, some software that provided by Esri such as City Engine, such as ArcGIS Pro, and all these software we all utilize these suites of software to basically utilize them to interpret the spatial sciences. So we have the screenshot of the body of knowledge of geographic information science and technology here. This body of knowledge has been updated multiple versions and is published online. So this body of knowledge basically includes all of the golden principles that we utilize in spatial sciences. So all the softwares that we use, plus the golden principles that we have here, is what we teach everyone here, with Spatial Sciences Institute. So the major that I would like to illustrate today is called GeoDesign. So probably a lot of you have not heard about this major, GeoDesign. The term is new, the major of course is new as well. So GeoDesign, the word is made up by two words, geo and design. So as we could already guess, GeoDesign, it basically is trying to do design in geographic context. So unlike the traditional design, such as traditional urban planning, traditional landscape architecture, we are actually trying to utilize spatial data and spatial sciences, spatial analysis, and use this knowledge to do data-driven design. Some of the key components about GeoDesign is, of course, is a design proposal. So we're trying to design as a force of good, to do something good, to do a project of good purpose. And we're also trying to plan. It also is a planning as a framework, use planning as a framework for collective action. And of course, we're going to use spatial sciences as well. Spatial sciences serves as a platform to support data-driven decision-making. So GeoDesign ultimately is trying to solve all the problems that we could see in either the natural world or our human world. So let me give you some examples here. If you're familiar with LA, or if you think about some engineering projects around where you are, we probably will see that for example, in LA, that LA River is a concrete channeled river, which, as we know today, the natural habitats has been destroyed and it's not a pleasant place. No one goes to LA River. So that the LA River was channelized under the background that it was flooded multiple times in history. So people thought, well, how can we battle flooding? How can we control it better? Let's use concrete channel to control river better. That was the old way of engineering. However, this group of designers in China, they used this approach that we're looking at here on the screen. Instead of trying to fight against flood, they're actually trying to make friends with flood. So they basically acknowledge that this city, yes, it does get flooded every single year. We are not going to change that. So how about we actually make a design that can be suited in both flooding season and also in drought season? So that actually provide people with the same kind of connection with this design, and it is trying to make friends with nature. Is a more sustainable design proposal. So this is an example of what GeoDesign is trying to achieve here. GeoDesign has already been utilized in a very practical way by city officials everywhere in the world. For example, this one you're looking at is showing you a GeoDesign workshop that done in Sydney back in 2016. So the group, as you can see, the group of officials in the photos, they're actually city officials from the city of Sydney, and they got together in a room and they're trying to figure out where is the best place for development or for zoning for Sydney in the future. So traditionally, when you think about this process, it will definitely take months, following the usual urban planning process, review process, so forth and so on. However, this workshop was done in 2 days. So imagine this, if you have a group of city officials and you have the spatial sciences tools, such as information you're looking at here on the screen, and people can really get things done very quick from a couple of months to 2 days. So that is also another thing that GeoDesign is trying to improve from the traditional planning and design principles, which is we are trying to have rapid design proposals and outcomes. And here is another example of some of the things that GeoDesign concerns about. For example, right now, Barcelona in Spain, they're actually the first city in the world that already make what you're seeing here, which is something called SuperBlocks, into action. So basically, Barcelona is trying to think about, well, how can we build the city into a less car-dependent and more walkable, more bikeable, more healthier city? So as we know, if we are trying to promote walkability, then generally speaking, the citizens will become healthier. So Barcelona come up with the SuperBlock idea. So what is SuperBlock? SuperBlock basically is talking about that instead of looking at urban blocks as what they are today, right, as just like urban fabric and surrounded by the streets, we are actually going to look at them as superblocks. And each of the superblock, inside the superblock, you only allow pedestrian traffic or bicycle traffic. And outside of the superblock, those major roads, then you allow, four-wheel vehicles. So this is another way that people are trying to think, to rethink, reimagine the city fabric so that we can have a healthier and more sustainable way of living. Besides, all those big ideas and, interesting projects, of course, at SSI, we're trying to teach students actual tools and skills in order to achieve those purposes. So for example, some of the very trendy topics right now in spatial sciences, such as indoor routing, such as how do you really incorporate a very detailed BIM model for architecture into your spatial context so that you can show different things at different scale. And speaking of digital twin, which is a topic that a lot of cities are trying to build, this kind of capability is important. So we're going to teach students how to do that as well. And another trendy topic these days are mixed reality, right? Virtual reality, augmented reality. GeoDesign also utilizes a lot of those mixed realities a lot. So for example, one example is FEMA. FEMA actually came up with a virtual reality scenario where they're trying to show citizens of different flooding scenarios inside their own community. And what if something happens? How do you evacuate out of your office, out of your home? So that is actually a very good experience, for citizens to understand what if flooding happens, what if earthquake happens, how can I leave my home? And speaking of some big concepts, such as, there are some European cities, they are trying to imagine this new forest city concept, which means that they're going to ask citizens to grow medium-sized trees from their own balcony. So that when you think about the cities, the buildings we live in, instead of a concrete, forest, it's actually going to be a forest. How do we actually visualize that kind of concept? We actually can visualize that with some of the 3D models that we have. And here we basically offered 2 general degrees related to geodesign and spatial sciences. We have the BS in geodesign. We also have the BS in global geodesign. The two majors are very similar in the way that they offer the same principal geodesign courses. The only difference is that global geodesign degree offer you the opportunities for you to study at different international global locations, such as Netherlands, China, and Australia. And both degrees are a joint effort from Spatial Sciences Institute, School of Architecture, and School of Public Policy here at SSI. We also offer 4 general education courses that's related to spatial sciences to all the undergraduates at USC, basically to inspire their interest in spatial sciences. All right, I'll turn over to Dr. Fleming to keep talking about our other majors.
Hey, thanks, Dr. Dewan. And so what I'm going to talk next to you all about and close up the presentation here is this concept of human security and geospatial intelligence. So unfortunately, there's things that go on around the world that create unstable conditions, and they can be caused from many different things, whether it be natural disasters occurring, obviously conflict, but we unfortunately have conditions where we have to try to figure out how to manage areas of insecurity. And so this concept of human security and geospatial intelligence is becoming more and more and more relevant as we continue to take on some of the challenges of the world. So we've placed some emphasis on this in building some programs within spatial sciences. So this particular degree set talks to some ways that we could address those issues that I mentioned previously. Again, we use, just as with the geodesign concepts, some literature that helps us understand what the body of knowledge is that we need to be addressing inside the classroom. I see in this particular description here is the intelligence community. We also get guidelines on what they're expecting us to do and how we are producing folks that are going to work in those communities in order to build our curriculum. As mentioned previously by Sean, a lot of the same folks that he had on his slide, you're going to see actually on this slide. We didn't coordinate that in advance, but the things that you see here and some of the partners that are interested in some of the technical applications that we're working on as part of this particular degree field are listed here. So a lot of the folks that you probably hear quite a bit about that work in this space are the ones that we obviously work with in academia. We've been building a lot of these degrees on kind of a fast track. So this is a very quick build of academic programs. For those that have been around academia, you probably have an appreciation for how did you get to a number of degrees and certificates that have been credentialed and accredited by the organizations that need to put these degrees in place in a fast way. So from certificates to minors to majors to bachelor's degrees and master's degrees, we've been able to get this done really in the last 6 years. And some of our folks that have come from these programs are now serving in different places around the nation, and a lot of what we think of as our human security geospatial intelligence focused activities. So those could be with the support agencies that we often hear about, veterans organizations, active duty military folks that are going on to serve in many of these different roles. So a very hot area that we found a lot of folks moving into. I can think you can probably reflect right now. Unfortunately, if you're watching the news every night, you're seeing a lot of things that are being discussed and talked about between Russia and Ukraine. A lot of those products that we're seeing as ways of demonstrating what's going on are products that have been built by spatial scientists. All of those mapping products, all of those Intel products that are now available for us to use are built by spatial scientists. Okay, I think those are the things that we wanted to talk about today. So we'll look forward to your questions that you may have on geodesign, human security, and geospatial intelligence. Thanks.
Great, thank you so much, Dr. Dewan and Dr. Fleming. This was a wealth of information from all three of our colleagues from across the country. And what I would like to do now is we want to open it up for any Q&A. So feel free to put your questions in the chat if you have them, and I will read them for everybody to hear what your questions are about any of these degree programs, which it's fascinating how there was an intersection, I think, among and between them in lots of different ways. So I think everybody walked away with some great kind of information and opportunities, right, of kind of things going on real world. So it looks like we have somebody who has raised their hand and has a question. So I'll go ahead and let them, if you want to go ahead and unmute. You can go ahead and ask your question. Let's see here. Actually, there is a question in the Q&A section. So Dr. Fleming, what coursework are you looking for in prospective undergraduate students?
Yeah, so a great question. The first courses that we start with are courses that are in geographic thought. Let me make sure I'm understanding the question that you're asking. Are these courses that you need to have before you start our program, or courses that you would take while in our program?
So the way that I interpreted the question, what coursework do you want high school students and to have coming into the degree program?
Yeah, so and Sean actually mentioned it quite well when he actually laid out for us the proper sequencing of what we often call STEM. So STEM, science, technology, engineering, math, the order is really wonky. It's not the right order. It really should be called MSET, which is math, the language of science, science, the phenomenology of the physical earth. If you like to build things, break things, fix things, that's an engineer, all enabled by the latest technology. So if anyone wants to argue that the George Washington Bridge is not a phenomenal engineering design, we can have that conversation, but it would likely be built maybe differently today and quicker, but not through different math and not through different physics and not through, all of those things are still in play. So I would tell you as a backdrop to the answer to the question is, you need to be good in math and you need to be good in science. Computer science we use quite a bit of, and we use a lot of computer algorithms in a lot of our spatial science software. So I would say you need to be comfortable in and around a computer. The other thing I would say, if you have any desires to understand how some of these really new and fascinating technologies of airborne collection systems, remote sensing, global positioning systems, how those things work, I would encourage you to try to find out as much of those things as possible before you come. It'll just place you in a better spot when you actually show up in the classroom.
Great, thank you. So we have a lot of questions rolling in. I'm going to go to the next one that was asked. Is the admissions process different, also meaning possibly more difficult for these very interesting and highly technical majors? So who wants to start first by maybe talking? Go ahead, Sean, we'll let you start by talking about how is the admissions process? Whoop, you're muted.
Sorry, Zoom file. I was just talking to my students about the standard year muted Zoom file the other day. I think the admissions process is essentially the same all the way around the board if it's an engineering program, because we're basically looking at what the students come in with the different math and physics or chemistry. I was answering in the chat that essentially when they come in, it may be an issue of how capped the program is in enrollment. So that may be the only real difference that I see. But as far as SATs, we're an SAT optional school right now at RIT. And GPA, I think the rest of that, it's pretty much a standard thing. So I hope that addressed the question.
Brian, do you want to say anything at all about what you're looking for urban technology preparation?
Sure. So our program is technical, but not quite as technical as the other two programs you all learned about today. So, we're not requiring anything in particular in terms of, taking calculus, for instance, as long as they've taken a traditional high school curriculum across natural sciences, social sciences, math, English, we're good. But what we're looking for in our students is we want to understand what or in which ways they care about their community. And we want to understand how creative they are. And so those are the two things that we're looking for. And that can be expressed in form of co-curricular activities, in things they're doing completely outside of organized activities on their own as experimental or entrepreneurial endeavors. Or likewise, even just in the writing that they bring to life. And so we're taking a very inclusive approach at the moment.
Thanks, Brian. Dr. Fleming and Dr. Dewan, do you want to answer anything at all related to that?
I would add one thing and let her jump in. I think especially in her field with the geodesign and some in mine, the idea of being able to interface with new software applications and working with those new applications in order to solve problems. We're seeing quite a bit of development in this field, and some students are interested in designing the applications as much as they are interested in using them. But her field is absolutely fascinating. Some of the things they're doing in 3D modeling and the interaction between what we think of as 3D data, where you're looking in the world in 3D space, and the modeling, simulation, and gaming, which we really like to think of modeling, simulation, and interaction, where you're interacting with the data much more robustly than ever before. Tremendous activity there, and I know in her field it's imperative that they do that kind of work very, very well.
Yes, I would say that so probably the most important quality for students is basically curiosity and creativity. So that is the best way, to learn geodesign in the future, and that would be the best quality to come into the program, I would say.
Thanks.
Great, thank you. There's been a couple more questions in the chat, but they've been answered by our panelists related to, graduate schools that students are going to, and the current state of the job market, which is so hot that it's hard to convince students to continue their education. Does anybody have any other questions? You can use the chat, you can use the Q&A portion to pose your questions. We've got just a couple minutes left because we do want to wrap up on time. So we appreciate you joining us. I'll give it 30 more seconds to see if we have another question that comes in.
While we're waiting on that, I would just say that in all of these dynamic disciplines, that your approach should be that you're a lifelong learner, and that in a dynamic discipline, you need to embrace the idea that you need to be learning all the time. The other idea that I would encourage you to think about, and it's very difficult for someone who teaches to state, but here's the statement, and it came from a guy named Alvin Toffler. The illiterate of the 21st century will not be those that cannot read and write. It will be those that cannot learn, unlearn, and learn again. And so it's hard for me to stand in front of a class and tell students that what I'm telling them part of what I'm telling them may not be relevant a few years from now, but something better will be. And so I think in dynamic disciplines, like many of ours are, you have to embrace that concept and then figure out how to put along your path journey of professionalism, the education and training that's going to come with it as an expectation of success.
Excellent. Those are some good concluding remarks. And I want to take this opportunity to thank Dr. Dewan, Dr. Fleming, Dr. Rummel, and Brian for joining us for today's panel about all of these unique degrees. And thank you all for joining us. And we'll go ahead and wrap this up. Enjoy the rest of your day. Thank you.
Thank you.
Thanks, y'all. Stay well. Be safe.
Thank you.